All right, welcome new folks. So give you once a month for people interested in Ruby and Ruby on Rails and related technologies in the Washington, D.C. area to get together, see some presentations, go to a little happy hour afterwards, and learn new stuff, meet like-minded folks. We try to cater to, as best as possible, all levels of experience, from people who are just wondering, hey, what is Ruby and Ruby on Rails and what are they all about, to folks who use them every day. We owe a big debt of gratitude to Logic. Guys, raise your hands. Thank you, folks, for hosting us every month. For those of you who have not tried to organize an event in Washington, D.C., which is probably most of you, I know you know the pain that is involved in that. Finding a space that is metro accessible, free, and sizable is no mean feat, and so we are very grateful to them for helping us out with that. Logic is an e-discovery company. They do some work with Ruby on Rails. Are you guys hiring folks, or any announcements? Okay, well, if you're interested in finding out more, you can speak with Vinny. I also want to thank Intridia, who are the sponsors of the group and who provide the projector and refreshments. Intridia is a DC-based consulting company that deals with Ruby on Rails and mobile applications. Let me see what else we have. Also, this is a good opportunity for folks to network. So let me just ask real quick, another show of hands. Who is looking to hire? And we'll start around the room. Okay, we'll work our way backwards, starting with Michael.
Hello, my name is Michael Lovitt. I work at SB Nation, the media technology startup here in DC. I'm going to be presenting here in a second, so I'm saying some more stuff in a second. But we're looking for developers and for designers. We have a big Rails platform looking for great Ruby developers and designers as well. So I actually put some handouts in there, some business cards and some little SB Nation handouts. So come talk to me or grab one of those things if you're interested.
And I work there too, in the interest of full disclosure. So you can talk to me about it too if you want to find out more. Josh, I think you have your hand.
Yep, I'm Josh. I'm a tech shop at a company called Toro. We sell stuff online. We have a e-commerce website, blinkq.com. It's Sprout Core, based on Rails stack. We have an internal, huge, giant, 120 model Rails application. Interesting things, a lot of big data analysis issues, a lot of just day-to-day dealing with products. It'd be fun if you're interested. We're looking for a couple strong Rails developers. Definitely go talk to them.
Awesome.
I know of two jobs. One is just a 4-week gig for JavaScript developer, and then someone else, Browser Media up in Maryland, is looking for a full-time Rails developer for a new project for combination of Rails, social media with mobile stuff.
Well, I know of a job as well. Social Code is hiring, but it's Python.
Okay. I saw some hands in the back. Yeah, Ruth.
I don't have a job announcement, but I organized the local Erlang meetup group, and we have a meeting this Tuesday. It's going to be someone talking. Troy was actually here, and it's talk to us about a virtual XMPP virtual hosting XMPP application they built with the Erlang, on top of eJAPD and Nitrogen. So just check it on meetup.com. Just look for Erlang if you're interested.
Cool, thank you. Just a little bit later, we'll get into just general announcements. So no sweat, but other people with job announcements. Dan.
Dan Mayer. I work at Living Social, and we're growing like crazy and doing everything back end, front end, and mobile. If that interests you, let me know.
I thought I saw another hand in the dark somewhere. Did I? No? Okay. All right, other announcements. Luke Scott his Erlang meetup group. That's on meetup.com, right?
Meetup.
So yeah, just search Erlang DC and it'll, I'm sure, be the first result. Jim organizes, well, you can.
Yeah, I organize Arlington Ruby. We're, I think, like 2 months old now, so we're always looking for presenters. It's a bit of a smaller group so far, so if you're interested in presenting, it'd be a good place to come and practice and get some feedback before coming to a bigger event at DCRUG. We're meeting every 2 weeks, so we're trying to keep a fast schedule.
Yeah, Lisa.
My name is Lisa Schaefer, and I'm applying for a research grant with the Air Force. the idea is a really, really cool project. It'll involve mobile and a lot of visualization. Jim is on board with me, but all I need right now is somebody who might be willing to work on this probably in 6 months from now. I don't really, there's not like a scheduled time when the proposals are accepted, but I need to have the likely people who are going to work on the project a piece of their resume in the proposal. So if anybody's interested in maybe doing like a 6-month project part-time, about 6 months from now, let me know and we can talk about it.
And then you're looking for Rails developers to work
It doesn't
on,
have
or-
to be Rails, but it might be.
Okay. Other announcements? No? Okay, cool. Running with what Jim said, we're also always looking for presenters. It's a big part of what makes this group go and makes it happen and makes people come and makes it worth your time. I see a lot of familiar faces, some of whom have presented before, some of whom haven't. You are both eligible to be presenters at the July, August, September, October, etc. DCRUG. So if you have any topic related to or on Ruby or Rails or related technologies, some of our concepts today are not, Ruby specific. We, Luke did a presentation on Scrap Core. Backbone is a JavaScript MVC framework. It's not strictly speaking Ruby or Rails. There are topics that you're interested in learning more about. Giving a presentation is a great way to do some research and put together, I guess, a coherent narrative for your own benefit too about what it's all about. So please be in touch with me via, you can just email me via the meetup group if you'd like. It's, like I said, it's cool if you've presented before, it's great if you haven't, and I'm happy to help you out in either case with some, pointers and guidelines. As I mentioned previously, there's also a social component to this. After we have our presentations, we go up the street, kind of out in 2 lefts to this place called RFD, Regional Food and Drink. It's this bar about a block away. They have good beer selection. I don't know what else they have, but I'm sure they have stuff that's friendly to people who are allergic to mold or don't drink or what have you. Given that it's called Regional Food and Drink, please come check it out. Usually we've been going to Rocket Bar, but that was a little too crowded and noisy, and so this place is a little more conducive to conversation. So it's just a block further. It's still in the same neighborhood, not far at all. We'll be going in, I guess, batches of us after the RUG ends, and then I guess without further ado, I guess we'll get started with our presentations unless anyone has any additional announcements or questions. All right, excellent. Then we'll start. First, we're going to have Michael Lovitt present on Backbone.js.
Okay, hi everyone. My name is Michael Lovitt. So before, I'm a developer at SB Nation. We're a media and technology startup here at DC. And today, we're going to talk about Backbone.js, which is a MVC framework for developing complex JavaScript applications. And so the agenda for today is, first we're going to try to answer the question, why Backbone? What problems is it trying to solve? Why does it exist? Why do we care? And so forth. Then we're going to look at how it goes about solving those problems. What is it about the approach that Backbone takes to architecting JavaScript applications that makes it suitable for developing big and complex ones. We're going to look at some code samples. Working with doing some of the things you do most frequently in Backbone, which is kind of working with models and working with views. And then we'll take questions. But definitely feel free to stop me during the talk. And if that matter, if I'm going too fast or going too slow, if I'm not making any sense at all, please tell me that. All right, let's dive in. So why Backbone? So without the right approach, JavaScript-heavy applications inevitably evolve into unmaintainable spaghetti. So if you ever worked on JavaScript application before, you've probably at some point in your career gotten in this position where it starts off kind of simple, feels like it's making sense, and then before you know it, it's just a big mess. And so the question is, why is this? And so to answer that question, kind of helps to think about what is a complicated, what is like a kind of a rich client-side application doing? What is it responsible for doing? So like think about like during a given user session on a rich internet application, the JavaScript front end is kind of doing these three things. It's keeping track of all the user's actions, either by kind of like monitoring what's happening in the DOM, or trying to stash things into the DOM, or by kind of like tracking those things, tracking those actions in its own kind of custom object at the JavaScript layer. It's also updating relevant bits of the user interface in response to those actions. And it's periodically sending updates to and processing responses from the server. If you think about like a web application like Gmail, imagine a situation where you've got like your inbox, you've got an unread message in it, and you click on that unread message. The web application's got to say, okay, this message that the user just clicked on, this thing, I got to mark this thing as being unread, or as being read now. So like update whatever internal representation I have about that, and mark it as read. You've got to update the UI. You've got to like switch the main view from the inbox to like actually looking at the message that you just clicked on. You've got to update the little bit of UI next to the inbox that states how many unread messages you have. And then of course like a message has to be sent to the server, to let the server know that, hey, this user just clicked on this message and it's no longer unread. So it's clear that like a rich client-side app has to do a lot of stuff on its own. When the user takes an action, the app often has to respond to that action directly without talking to the server. Like probably the reason you're developing a rich like client-side app is that you want to be responsive, you want to do things kind of fast, you want to feel kind of like a desktop application, and you can't be waiting for the server to tell you what to do. So you as the kind of client-side app has to figure it out for yourself. So therefore, you have to be smart and you have to be stateful. Client-side app has to manage both the application state and the user interface views on that state. And in a complex app, a single user action may trigger many state changes, and a single state change may trigger many UI changes in turn. And so, in the big applications, you're trying to manage all these things. You're listening to events in the view. You're updating your own kind of record of what's happening. You've got jQuery selectors. You've got callbacks. You've got all kinds of crazy stuff happening. The traditional or kind of like a naive approach, your code's gonna get ugly if it tries to like glue all these different pieces together. So this sucks. It's like no fun to work in. An application like that is not going to be maintainable. It's not going to be pleasant to use. It's going to be hard to test. So it's clearly not the situation we want to be in. And so enter Backbone. And so the Backbone approach. So Backbone is it's an event-driven MVC. So it's an MVC framework. We're all probably familiar with Rails, so we kind of know what MVC is. It's about separating out concerns, like we have something that's a model, we have something that's a controller, we have something that's a view, and those things are responsible for doing different things, so we should decouple those things from each other where we can. But Backbone is also like an event-driven framework. And so in Backbone, models fire events when they change. So if you're building an email client, you're probably going to have a model for emails. Each email is going to be represented by a model, and if in your application one of those emails changes, if it changes from unread to read, then that model is going to fire an event to let anything else in the application know who's interested in knowing that that model just changed. So models are firing events when they change. In addition, the UI in the Backbone app is divided up into self-contained views that can listen to those models. And so you can imagine a big again, like something like Gmail, which is kind of like a complicated application. It's like a big screen, all kinds of stuff happening. That user interface can be divided up into little self-contained chunks that know how to render themselves and that can listen to models and be informed about when they should render themselves. And so the control flow in a Backbone application like this what happens is, you know, if a user clicks on an email to mark it, to change it from unread to read, what the application is kind of responsible for doing at that point is making that change, that state change in the model only. And that's kind of like just that's what the app does when that happens. But because views are listening to events and models are firing events, views that care about those particular models are notified when those models change, and you know, they can update themselves in response to those changes. And so, you know, yeah, so a view that cares about a model knows when a model changes and can kind of like re-render itself in response to that change. So this is pretty neat. Like models can be decoupled from views now. You know, so our models in the Backbone app can now kind of be like pure, clean models. You know, they can start to look more like a Rails model. They don't have to be aware of the DOM or HTML or anything like that. They can just be concerned with kind of like the business logic around the model. And views can be decoupled from each other. You know, in Gmail, the little indicator next to the inbox that says how many unread messages there are, but that thing could be built out as a single view that only does that one thing, and it doesn't have to be concerned with anything else in the application. And all the views in the Backbone app are like that. They're kind of these independent, or they can be independent, self-contained bits of UI. So this is pretty sweet because you know, kind of like a tangled mess of functions that we would end up in with the naive approach. You know, we kind of like imagine that's kind of getting untangled now, and the things that can be decoupled from each other are being decoupled from each other. And you know, because your application now kind of getting divided up into these logical units, it's going to be more testable. You know, if you want to write tests for all your models, you can do so pretty easily because those things aren't, you know, they don't have any relationship to DOM elements or HTML fragments, and it's just you know, pretty pleasant to work in. So the stuff we just talked about, the fact that it's an MVC framework, and you got models that are firing events, and you've got self-contained views, that's kind of like the core of Backbone. That's kind of what makes it possible to write big complex applications that don't turn into piles of spaghetti. But Backbone provides some other like pretty neat things that are worth going into. It also provides you with controllers that route URLs to views. And so, you know, in a JavaScript application, you know, you might want to be able to provide kind of like bookmarkable, like shareable URLs to a piece of state in your application. And so the way you do that is you kind of update the fragment at the end of that URL, and you need to, you know, if that URL is requested, you have to be able to detect that, okay, this user is responding, this user is requesting a URL of this particular fragment, so I got to load up my app with this piece of state turned on. And so Backbone provides controllers that makes it super easy to do that. You can kind of think about them as combinations of like a Rails controller and also like the Rails routing file. Like they're responding to URL fragments, and they're kind of like in response, like doing something with views, rendering a view. So they're pretty cool. So also in a Backbone app, you're generally using like ERB style templates for rendering views. So this isn't really like a feature of Backbone per se, but it's kind of like part of the Backbone way to set things up this way. I had actually never used JavaScript templating at all before I started working with Backbone. It's like a total breath of fresh air. You know, I don't know. Like I definitely ended up in situations before where I did not want to, but for some reason I had to end up like concatenating strings together in some JavaScript function to build up a chunk of HTML markup to then like shove into my view. And that's always messy and it's no fun to do. But with the JavaScript templating engine, you kind of like set up a template the same way you set up like an HTML or an ERB template in Rails, where you have like variables in it and maybe some simple conditional logic, and like all your kind of like markup viewy kind of code like lives in that form, and it's really super pleasant to work with. So Backbone also provides standard means of syncing client-side data with the server. So it kind of assumes that your server-side controllers are kind of like RESTful. You kind of have like resources set up, and assumes you're going to be passing data back and forth with JSON. And you can override those defaults if you want to. If your server side is not RESTful, and if you don't want to use JSON, you can set up this server synchronization however you want to. But if you want to go with the defaults, it's super easy to get data down from the server and then push it back up again when it changes. So that's pretty great. And then this final thing here is like, you know, kind the important thing, it's like obvious by now. Backbone provides like a clear path towards structuring large, complex JavaScript apps. It actually doesn't have a lot to say about like how you organize your classes or like where you put them in the file system, like what folders you put them in. But once your application is divided up into models and views and kind of these like logical chunks, it becomes pretty straightforward to figure out how to organize those things. And again, more maintainable and just more pleasant to work with if you're able to do this. So when do you use Backbone? So this is probably obvious by now too, but Backbone is obviously like best suited for building rich client-side web applications, not web pages with a few JavaScript-driven features. If you're just adding like a drop-down menu to your otherwise static page, it's probably not going to make sense to use Backbone. In general, if you use Backbone, you kind of want to go all in and have Backbone like managing most of the interactivity of the user with your application, and your server-side kind of controllers just become more about being a data API to your JavaScript application. And then you don't want to use Backbone if you care about degrading gracefully. You're writing a Backbone application, it's gonna depend on JavaScript. If JavaScript's not around because the user disabled it or whatever, your application's probably not going to work. Don't use it if you care about that. So what Backbone is not? It's not a collection of UI widgets. There are lots of frameworks that are a collection of UI widgets, but Backbone is not one of those things. So it doesn't have much to say about kind of the, what's your view like looks and feels like, or the specific kind of UI excuse me, elements you have. It's more about kind of like organizing your code base and structuring your application, and you're left to figure out like how your application kind of looks and feels on your own. And it's not Rails or Ruby specific at all. I keep mentioning Rails because it's like something we're familiar with and it's a useful example, but you can write a Backbone app on any server-side framework. Okay, so now I want to like kind of like take a step up and kind of look down at some of the pieces we've just talked about and some pieces we haven't mentioned yet, and kind of see how they all fit together. So it's kind of like the Backbone. This is the Backbone universe. And so, the first thing to look at here is models. Again, this is a model is a model. A Backbone model is really similar to a Rails model. Wraps a row of data in business logic, fires events when it changes, yeah, it's a model. So another thing, or kind of a new thing we haven't talked about yet, is collections. And so collections, a collection in a Backbone app is a list of models of a common type. And a collection has logic for kind of like getting at those models in that collection. It has logic for sorting and filtering and so on. And collections also broadcast events when they change. So if you're a view or something else in the app and you care about what's happening with the model, you can either listen to a particular model, if that's all you care about, or you can listen to an entire collection of models and be notified when any of them change. And also be notified if a model gets added to that collection or gets booted out of it. And then we have templates that I talked about just a second ago. Again, these are just like ERB style HTML chunks. We've got variables in them. They've got some conditional logic. And they're used by views to so basically a view is going to be listening to models. It's going to be getting data out of models. Then it's going to be grabbing templates, finding data from the models into those templates, and then rendering themselves. And views are also responding to UI events. If you've got a to-do list application and you've got a view that represents a single to-do item, and that item gets checked, that view is responsible for listening to that check and doing something in response. And that something is generally updating the model that backs that view. And the final thing here, this diagram is controllers, which we've already kind of talked about. Again, a controller Backbone is like a hybrid of a Rails routing file and a Rails controller. It's binding URL routes to methods that it defines, which typically instantiate and render views. So that's the Backbone universe. And so here we have a list of dependencies, kind of like in tools that are used in it, or that can be dependent on underscore.js, which is kind of a JavaScript utility library written by the same author of Backbone. Provides, it's similar to Prototype, and then it provides kind of a bunch of handy methods for iterating on collections and kind of some Ruby style methods like map and inject. And but it sticks all those methods onto kind of a global object as opposed to spreading them all throughout the built-in JavaScript objects like Prototype does. So underscore is like lightweight and pretty handy. Then Backbone's also dependent on either jQuery or Zepto. You got to use one of those. It's recommended to use the JSON2 library for browsers that don't natively support JSON serialization and deserialization. That's something you just kind of include in and don't think about. And then it's recommended to use the templating engine we've already talked about. And then another thing worth mentioning here is Jamit, which is it's a tool for it's a Rails-based tool, or it's a tool that works with Rails applications for asset packaging. So it's generally pretty handy for just it's one of these tools that takes all your JavaScript files, bundles them into a single JavaScript file, minifies it so it's as small as possible, and then that single bundle minified file is what gets sent to the user. It gets sent to the browser. So it's obviously going to be useful for us when we're writing a Backbone app, because we're going to have tons of JavaScript files. We don't want to have at least like 20 different files in our markup. It's especially handy for dealing with template bundling. So basically, like when you're working with JavaScript templates and you're working with Jamit, you can set up all your JavaScript templates as like individual files. You give them like a JST extension. You stick them alongside your Rails views. They're going to look a lot like Rails views in that way. They're going to be like barely distinguishable from Rails views. And Jamit kind of automatically like goes and finds. Well, you kind of tell it where to look, but if you told it where to look for those JST files, it goes and finds them. Kind of like gobbles them all up for you, and then makes them available to your app via kind of a global object. So it's just kind of something you set up, and you don't have to worry about it anymore. You can kind of like organize your code in a sensible way, and your templates are just available in an easy way for your app to use. So Jamit's really sweet. If you're working with Backbone and you're on Rails, I would definitely recommend Jamit.
So it can be used like completely independently from Rails, right? The reason I didn't install it was because it seemed like it was meant for Rails and had to be used with Rails, but you don't have to have any Rails files in there.
For Jamit?
Just for Jamit. You can just have like pure JavaScript.
I think, so it definitely advertises itself as being Rails only.
Right.
Like, I think that's probably because it has hooks for, if you're working in development mode and you like request, and you kind of update one of your JST files, Backbone like automatically will kind of like bundle those things up, and it's kind of like tied into like the Rails request. It goes and gets those things and kind of makes them available dynamically, as opposed to doing it like manually like before you try to request the URL. So I'm not sure if you can use it outside of Rails actually. Right. Maybe you can use it in some manual way, or you could like hack it to work, but I'm not sure. Right. So next we're going to dive into some quick like code examples. It's already like too deep into code about a projector like this, or at least I can figure out how. So kind of like have some really like kind of simple code examples that kind of go through some of the common things you do in a Backbone app, kind of working with models and collections, and then working with views. And so I pulled these examples from the todos.js app, which if you start working with Backbone, you run across this pretty quickly. It's kind of like a sample application linked from the Backbone homepage. It's got annotated source code, so it's kind of a good way of getting familiar with Backbone. So I kind of pulled some of these examples out, and I stripped out a lot of stuff, and I kind of just I got them to the point where we can see them up on a projector and look at some specific things. So anyway, this is the so this is for like these are going to be the models and collections and views that back up To-Dos app. And the To-Dos app, it has things you want to do. There's like a checkbox, and there's like a label next to it. This is my to-do list, and I can check those things off as I complete my to-do list. So, here on this slide, we're basically defining first we're defining a model, and then we're defining a collection. And so we can see here we're defining this model called to-do. And this, again, looks kind of, this like format looks familiar. There's a backbone.model class that we inherit, that we extend to make our to-do model. So it kind of feels like you're setting up a Rails model. You've got some, you can set some defaults here, so that basically every instance of a to-do will automatically get these properties here. And you can set up validations, again, similar to Rails. So this validate method will be called whenever new properties are set on the to-do, or if the to-do is saved. And if you don't return anything, the validation passes, or if you return anything, then that's a failed validation. So you can just return a string, or you can build up more complicated, kind of custom error objects. And so, of course, in this a real application, you would then fill this out with all kinds of other, logic related to-dos, so that's a model, and then collection is right here. So this is our to-dos collection. This is the thing into which we're going to stick all of our to-dos. And you can set up a collection without writing too much code. Kind of like 2 bits of configuration you need to give a collection. One is the kind of model that collection is going to be dealing with. And then, so in this case, it's to. And then the second thing is the resource URL for that model on the server. Basically, Backbone uses this URL format to generate. It assumes that a to-do with ID 1 is going to be a to-do /1, and so kind of builds kind of predictable style URLs based on this kind of config URL that you give it. And so once you give it these 2 kind of configuration options, then kind of all the server synchronization magic can kind of just work for you. You can then start saving to-dos. You can tell your collection to fetch all the latest to-dos from the server, and everything will just kind of work. So that's pretty neat.
It's assuming there's a RESTful server. Do you know of any sort of off-the-shelf RESTful servers for that kind of stuff?
I mean, if you're using Rails, you can if you just set up if you set up a to-dos controller, and in your RAS file set this is a resource. Right. The to-do is a resource, then all of the kind of default actions and URLs that Rails spits out for you are going to work out of the box with this. So yeah, just kind of. I think the guy who wrote this, they're working with the Rails application, so it works pretty well with Rails by default. Does that answer your question?
Yeah.
Okay.
It is.
Okay, cool. So next here, so we've defined a model, we've defined a collection, and the next thing we want to do is actually try to use those things. So here we can instantiate an instance of the collection. This is something you typically would do once when your app is starting up, depending on what you're going to do with the collection. You probably do this once. You make your to-dos collection. Now we're going to use this to-dos collection for the kind of the lifetime of this app. So that's how you make your collection. Then if you want to create a to-do instance, say new to-do, you can pass in a list of attributes that to-do will get. So this to-do is going to get content of that string there. And then here, it's pretty straightforward. We're adding a to-do to the collection. And so when we do this is when the event fires. The collection's like, hey, somebody just added a to-do to me. So anybody who's listening to that collection will be notified about it. And then if we save the to-do, a couple things happen here. One, the event is fired again. Anybody who's listening to this particular to-do will be notified. And then by calling save, we're going to persist it to the server.
When do validations get fired?
So validations get fired at 2 different points, I believe. So if whenever you set attributes to a model, validations are going to run, and then I think they also get fired again once you save it. Yeah. And so okay, so that was models and collections. So now we're going to define an actual view. And so this view here would be a view that backs one particular to-do. So this view would probably have a checkbox and a label that displays the content of that to-do. So there are a few things to look at right here. So we have provided an events object here, which basically maps events that are happening in the UI to methods that we define here in the view. So we're saying, okay, if somebody clicks on an element that has a check class, then we want our toggle done function to be called. So there's a pretty straightforward way of just kind of binding events to event handlers. You can imagine a more complicated view would have all kinds of events declared up here. So that's pretty handy. And so when somebody checks that box, toggle done is going to be called. And here, this is the point where we're, we have a model. If you're back, there's a convention in Backbone where if you're a view and you're backing a specific model, you're set up to have an instance property called model. So you can call this.model to get to it. So somebody's checked our box, we know that. So we need to set this attribute in the model based on what just happened in the view. So we're setting our done attribute to grab the checkbox and we see if it's checked. So it's return true or false. And we set it into the model. So one thing to note here is like we're using the jQuery $, but if you invoke it on the this object, it basically automatically gets scoped to the DOM element that's associated with this particular view. So if there are a bunch of elements on the page with the check class, we don't have to worry about that. We know that this selector is only going to apply to checkboxes inside our view. Because there's only one checkbox, we can just get it easily just by doing this. So again, that kind of like just reinforces the kind of like a self-contained notion of views. Keeps your code a little bit cleaner. And so, final thing to look at, let's look at back up down, look at the constructor. So when this view gets instantiated, whoever instantiated this view, kind of like we won't look at code that does this, but whoever instantiated this view like passed in the model for the to-do that this view is gonna back. So here, this is how we actually bind an event, or bind an event that's going to be fired by the model to a method that's defined during the view. So we're just saying, okay, anytime this model changes for whatever reason, we want to re-render ourselves. And if this were like a real view, we would have a render method defined down here where we set what it meant to render ourselves. We'd probably grab a template and grab what to do, and find some data into it, and then update our DOM elements in the DOM. So by listening to change, what we're saying is if any property at all changes, we want to be notified. There's also, you can, kind of like different levels of granularity here. We could also say change : done if all we care about is listening. If all we care about is knowing when the done property on this to do is changed. And say change : done, and this method will only be invoked if the done property on the model changes. So that's defining a view.
So before we move on, it's kind of interesting. I wanted to hear what you think about this, because it seems like this view has almost like two separate conceptually different aspects taking place there. There's bindings between like the UI events, and these events call methods that presumably only deal with the models. And then there are bindings that listen to these events that then update the view. So it seems like the view has like two conceptual things in there. It seems like the methods that deal with setting the models, are buried into the same object that actually updates the view from those models, right? It's almost like there's a controller sort of buried into there.
Yeah, that's true.
How do you organize that? Do you separate your methods? You kind of like, these methods only deal with listening for UI events, and these methods deal with updating the UI.
I guess one way to think about a backbone view is to actually kind of think about it as like a little controller. It actually like serves some of the same purposes that a controller in Rails would. It's like it is responsible for doing both those things. It's listening to user actions, and it's updating the model in response. And I don't know. So your feeling is it's just kind of like it's just messy to have.
Yeah. So the only way that I found like sort of to organize is I literally just separate. I use the methods that deal with like the model. I just put up on top, and the methods that update the UI I put at the bottom. But I was just wondering if there was like sort of a different way of going about this. But maybe at some point this is going to evolve and it's going to become like a separate controller or something. The framework will do that, but. It's just that conceptually it seems like it's begging for that separation, but
I don't know. Like when you're binding, I guess one thing is that kind of these bindings that happen to the model they're probably not going to be spread all throughout your code. It's probably going to be something you do
just
like once.
Initialize,
it's like I'm getting constructed. Okay, I got this model. Like I'm listening to the events on it now. I'm not going to be doing any more binding. And then the rest of your functions really are about setting properties on models and then responding when models are updated.
Right, right.
Yeah, but I hear what you're saying. It's a little bit strange, but I guess that stuff has to happen somewhere, and this is where it happens. Cool. Are there any more questions? Okay, sweet.
I got a question.
Oh, okay.
What exactly do the controllers do? I mean, it seems like they're just innocent bystanders.
Yeah. So the controllers do a lot less than like a Rails controller. They're kind of like orchestrating the views. It's like, you know, somebody requested this particular URL, and it knows that, okay, this URL corresponds to this view, and so I'll instantiate this view as a result, and then that's kind of all the controller does. So the controller might grab it might instantiate a collection, or it might instantiate a model. It might instantiate a view and kind of pass that model into the view, and then, you know, the view is kind of left to do everything else on its own.
It's kind of like routes.
So it's just basically a router.
It's basically a router. It's doing a little bit more than like the routes file in Rail, and that it's like kind of working with objects, but it is. That kind of weirds me out. I first started working with Backbone. So I'm like, well, there are these views here, but they feel like controllers, and there's this controller here that doesn't feel like a controller at all. And so the terminology is kind of weird. And if you go and like read the kind of the Backbone documentation, you kind of acknowledges that. It's like, here's how this compares to traditional MVC, and you know, you kind of think of your view as being more of a controller, and controller is kind of like a router.
Yeah, so this is similar to Nitrogen framework.
Is that right?
Yeah, it does about the same thing. I mean, you sort of define your view, what it looks like, and then your callbacks to update are also defined in the same module. It's in Erlang, but it really doesn't even have a controller.
Yeah, right.
But I would say it's not. Other people have done it.
What's that?
Other people have done this. So.
Yeah, no, that's true. This is, yeah, go to like a Wikipedia MVC page and talk about this is kind of like this is one way of doing MVC. Yeah. Very cool. Right, so here's just some, so we're about done here. So we guys got some resources here. So there's Hello Backbone.js. It's written by that guy right there. This is like a really cool tool. It kind of takes a really cool tutorial. It takes the todos.js kind of sample application, kind of breaks it up, and kind of like guides you through it in a linear way, kind of like building up a piece at a time. It's a much less like overwhelming way to kind of introduce yourself to Backbone. So that's pretty sweet. And then there's this cloud edit tutorial, and this is interesting because it comes with a sample Rails app. So you can kind of see how this guy has decided to organize his stuff in a Rails app. You know, where he's putting his models and views and stuff inside public, and how he's organizing them, and he set up his Jammet config, so you can kind of get a feel for how it's going to work with Rails. And there are a couple other links here as well. And so that's pretty much it. I'll post these slides if you want to get to those resources. I'll post these slides to Twitter. I'm at Lovitt, and I'll post it to the DCRUG message board tonight.
Yeah, there's an actual files section.
Oh, okay.
Excuse me. So if you can export this like PDF or something,
Just upload it there.
just upload it right there. Yep.
Sweet, I'll do that then. If you're looking for a new job, please let me know. SBNation is a great place to work. Let's set up some handouts in there, or you can just come and talk to me. We're looking for developers and designers. Thanks a lot for having me. And any more questions?
Yeah. Have you always worked on apps like from the beginning with Backbone? Because it seems all the examples I've seen with Backbone is fine and everything. They're new, fresh apps.
Yeah.
And I'm curious if anybody has experience converting existing like JavaScript and like application code over to this.
Yeah.
I've yet to see an example where you can kind of mix it in with a traditional JavaScript spaghetti code type of situation.
That's a great question. I've never done that, and I agree. I've never seen any examples where anybody's talked about doing that.
I'm dreading having to do that myself.
Is that right?
Yeah, I mean, there's thousands of lines of spaghetti code, and I take a deep breath every time I remember I have to, sort of organize it. But I guess that's, it's the problem with non-maintainable JavaScript code.
Yeah, it seems like it would be hard.
If you solve that, come back and give another.
Yeah.
You're right. Automatic background.
Compile spaghetti into the backbone. Yeah, go right.
I think we have a question.
Okay.
So there isn't any kind of auto magic between between Backbone and the Rails models. Say, for example, validation, does that automatically propagate to out there?
No, that's a good question too. There's not, and you start to feel like, oh, I'm starting to duplicate things that are in my Backbone models and things. There's nothing like that. Yeah, there's nothing like that at all. You kind of have to decide, okay, what do I care about, like asserting in Backbone versus what do I care about? What's more important to assert on the server? But yeah, there's no magic way that things get propagated back and forth.
You can fail like your active record validations, and if you fail on like the post, you can return that and enable the errors that way.
Yeah, you can do that. Go ahead, sure.
So, have you evaluated Scrap Core also, and what would you say versus Backbone?
Yeah, I actually haven't played with Scrap Core too much, to be honest. I don't know, my introduction to this was I knew the kind of app I was going to have to build. Like I knew kind of what the requirements were for like the views, and so I kind of like went looking for a framework that kind of met my needs. And this was, I don't know, this felt like safer to me. It was obviously lightweight. I could read all the source code and understand it. Like I kind of knew what I was getting into, and so yeah, I haven't had the opportunity to mess with Scrap Core much myself.
Do you know if anyone has tried to take the models, or is it even possible to take the models from the Backbone application and move them to, like, say, Node.js on the server side and reuse the code? I know that some of the Sparkle guys have had to make that happen.
I think somebody has done that. I can't remember. I remember reading an article where somebody totally did that. They they had like their client side stuff and they had their server side stuff, and they were literally reusing the same models. I don't know. Does anybody here know like? I've read that. I can't remember what the example was.
I know it's definitely possible. Like development C that around here does a lot of node work, and they've had no problems doing it. So yeah, there are resources for that.
How comprehensive is the object model? I saw you use extends, and I feel like every framework kind of invents its own JavaScript object orientation. Like, is it?
I think it. I don't think it does much other than extend, to be honest. I think I remember reading that in the source code. It's like they set up extend so you can do inheritance, and I can't think of anything else that Backbone provides you along those lines.
It's just basically extend and new throughout, right?
Yeah. All right, sweet. Thanks a lot, guys.
Low threshold for dealing with projectors. All right, next up is Darius Roberts. Why don't you introduce yourself and tell us all about genetic programming for the web.
Thanks, my name is Darius. I haven't been around for a while, but I used to come to these fairly regularly. It's a different group, so I'm impressed. It seems to have grown. I want to know immediately who here has experience with GP, because I want to watch out for questions. I know Artur.
That's what it wants.
Okay. Artur, I did. I think wrote a library on this as well. So anyway, okay. So I was actually expecting people to have a few more opinions. So this is mostly not a talk about concept. I feel like other people have done that better than I have, and there are excellent video resources on the web. I'll be referencing one specific talk that I think is pretty good, that is also Ruby-based. But I wanted to talk. I'll do a little bit on the concept, like 2 or 3 slides, and then talk about some ways that Ruby might be used, even though it's not the best tool for the job for most GP applications. Okay. So just very quickly, this is a stack-based GP, which means that it's the Revolve library, the one that I'm using as sort of the toy library to do this stuff. Basically, it has maybe 200 of these in a population. So any individual user in your system might have a population of 200, and just as an example, and it will go through this sequentially as a stack. Pop this onto either a letter stack or just a general permanent type stack stack. So it would basically build a stack with G at the bottom, 3 on top of that, N on top of that, 3 on top of that, T on top of that, 1 on top of that, C on top of that, S on top of that, and then it would add S and C, reverse Polish style, and then add C, S, and 1, and depending on whether your plus function allows integers to be concatenated to strings or not is up to you. That would error in this library code. So that's probably not enough to really look to see how it works. So I think we're going to do a demo pretty soon. First, I should say that I kind of have a quest. I just sort of decided maybe a year ago that I was going to figure out a way to make a website through GP or through artificial intelligence. So it's kind of a crazy quest. I'm just trying to figure out a way that it can work. I've tried a lot of things, and a lot of things haven't worked. But one of my favorite things that sort of kind of created an algorithm was a flashcarding website where I was taking the data off the website and creating an algorithm which classified a card as known or not known based on the previous pattern. So those are just a few things that I've tried. And I like the Revolve library because it's simple and it's a good toy to play with, as opposed to the things that I was handwriting before, which didn't work. Okay, so GP is they call it climbing. So different genes will try and climb to a local minima. Well, depending on how you set up your fitness function, it's really all about the fitness function. So, well, let me just skip on and actually show you an example. Hopefully that will make sense. Okay, so first I'm going to create well, let's look at the code first.
Can people see that?
So with GP you have to decide a few things. And this is pretty much all in one place. It's a big configuration. The most important thing is the fitness case. You have to decide what it is that is going to test each individual sequence stack in your population. In this case, we're looking for the stacks compilation it's run to have a value of 120. So we can throw methods in there. We can throw the same method twice in, which will increase its. Whenever you create a new gene from scratch or mutate an existing gene, which I'll talk a little bit about mutation later, you would want to pull it from a bucket of black balls. So you have constants and you have protected division, which is necessary. So this particular one is set up with a few configuration parameters. So size limit, the stacks can never be longer than 20. Elitism %, that means how many you're going to keep around to the next generation. You don't have to keep any, but let's say you have 21 in your population, you would keep around 7. And that just kind of ensures that you don't accidentally kill some very valuable genes between one breeding round and the other. So the 4 stages of GP are number 1, generate or produce. So you're producing a population randomly of 200 or whatever it is in this instance. Yeah, 200. You are after you produce them, you evaluate them for fitness. After you evaluate them for fitness, you select them, which involves just the elitism and also just creating parents. So which ones are you going to choose to breed for the next round? And finally, you breed them, which involves these three parameters, which are your crossover, which I can't go too far in detail. You really should check out Larry DL's, the Revolve libraries guys. But basically, you take, if this is a full gene, you take, you know, a fourth of it and 3/4, and then match it to another one that you cut in half as well. So in the end, you're taking two different genes and combining a random segment of each one. So you could end up with one really short one and one really long one, but you've picked a random point in each gene, sliced it, and spliced them. I don't think there's too much more I can really go into in this, this talk. I encourage you to actually look up some of the library. It's very clearly written, and some of the presentations which do it more justice than I can do. But it's all about the fitness case. So just to go back, it's produce, fitness, select, and then breed, and then repeat the cycle. But the fitness case is super important, because especially for my theory about how and why Ruby could be used in interesting ways for GP.
So like in this case here, what are you trying to evolve your population to do?
Right. So in this particular case, we are looking for a constant. So the constant is 120. So we're trying to create an algorithm that creates 120. It's not very interesting, but I'm just starting with a simple example. So it's going to grab sequences of these constants and these operations. So it's doing behind the scenes, but we can go and look at that a little bit more briefly. But this is the program that it produced that has the output of 120. So it's, I can go in and show you that, but I'll do that personally. How about squared? Yeah, that was ridiculous. It just picked it up in the first generation. Just randomly happened to generate one that solved the fitness function.
I think that's easy to.
Yeah. Okay. Yeah, it's gonna have to think about this one. We might just go in with debug.
Why don't you in the meeting just look at the first one?
This X variable one?
No, the very first one, the 120 example. So.
Okay.
So how does that?
So looks like -4 gets put on the stack, -5 gets put on the stack, -4 gets put on the stack. -4 and -5 gets multiplied, so that's 20. It subtracts 4 from 20, which is it adds 4 to 20. It's 24, and then it multiplies it by 5.
I think with -5 or
You have 20. Isn't it 20 plus 4? So 24 times 5.
yeah.
Oh, right.
20 and 24.
Right.
And just 120.
Thanks. It's good that the computer can do this for me. Okay, I'm gonna cancel
You
that.
can weed it out of your example.
Okay. Yeah, this is also on a tiny little netbook. My Mac decided not to have. So that was 11 generations, multivariate. Too shabby. Three generations. Okay, so gonna stick a debugger in. Is there anything in particular that we should be? Okay, so I think that covers the concept of how genetic programming works a little bit. It's creating random strings. There's a lot of tweaking of the variables. It's very important to get it very right, but when you do, it's magic. The most important variable, of course, to tweak is the fitness function, but everything is important. Let's see. So there's lots of other intelligent tools out there which don't quite do the same thing. So SVD stands for support singular
Value
singular value decomposition. So this is actually what eHarmony uses, for example, when it matches you up with your perfect love interest. It's just it's repeatedly taking out the largest vector that it can to explain the difference. And support vector machines are widely used now. They train on regression data. So if you have a whole bunch of data based on what people have done in past situations, you can get really close results to predict what people will do with what people probably might want. So both of these tools are optimization tools in some sense. Singular value decomposition, for example, if you one tutorial online by Iga Vita, I'm not sure, you enter in your ratings for a particular TV show, for a number of TV shows, and it'll decompose the users that are most similar to you based on those ratings. So that's an optimization, because then based on those users, it can tell you what users like you also bought. So it's optimization. It can get you 80% of the way there. GP, on the other hand, is not really an optimization technique. It's a perfect technique. So the goal is to get perfect. So one of the claims I'm going to make later is that the very few use cases where GP is a clear winner is when you need to get perfect, or you have data mavens that in your user base that you spend 90% of your time supporting 2% of your population or something like that. These might be times when people would spend the time themselves to help you to optimize for that. This is according to the standard text is what genetic programming in general can be used for. I'm going to state that what Ruby can be used for is a much smaller subset, because it's just not fast, it's not optimized. There's some people that say you can compile pieces of it and stick them together and get major performance improvements, but the libraries in other languages are more mature anyway, and there's other things. So the reason that the places that I think web development might be able to play with some or get some benefit might be when there's really subjective fitness functions. So for example, when I was trying to do flashcards, only the user really knows how well they know the card. So I'm trying to get what's in the user's brain mapped. So I can get at most maybe 1 to 2 tests of the fitness function per minute, because that's how often the user is clicking on it. So it doesn't really matter how fast Ruby is or is not at it, because I'm only moving at the speed, I'm only evolving or breeding at the speed of the user. And then I think that there might be some value in GP, because as opposed to GA, which is the superset of GP. GA is genetic algorithms, which generally just means tweaking parameters, so scalar values most likely. Whereas GP is actually creating sequences, which which you could think of as a program. So I think in a lot of cases there is a lot of value that you can see what is actually being put in, and maybe even users being able to contribute in their own you create some way that users can contribute specific genes into the system, which will help them to satisfy their own use cases, or at least tell you what they're trying to do. One thing that some people have claimed is that that Ruby's use of TDD gives us a lot of tests that we can then use to perform GP. A lot of these people are looking for kind of the pie in the sky, actually, developing entire, web pages that develop themselves, sort of like Jekyll, but from nothing to exactly what the user wants. Maybe a better example would be finding out a public API of some service, and then having a GP just develop that service by generating random Ruby code in intelligent ways to try and satisfy certain tests. That's kind of crazy, and I don't put it past that happening eventually, but I'm kind of interested just in the very specific use cases of what can we do today with that technology, rather than developing things that write themselves. PyEvolve is a library that's in Python. It's much faster than Ruby right now, but there's also lots of other interesting entries into genetic programming. One of my favorites is a JavaScript implementation of genetic programming that actually goes out and calculates all the fitness functions on your users' web pages. So it's using their CPU power to calculate fitness functions. I thought that was fun. So I was talking with a couple of people earlier, and a couple of the use cases that people had talked about would be, number one, you have, Vinny and I were talking about some of the data that's available for traffic and transit. So that's one case where a very few number of users want to know exactly what the fastest route to work is, and they will tell you what they want to see, and that could be a case where they would provide ongoing feedback to help you understand, help the algorithm develop a route that was exactly right for them. That's something that if you had Google-sized page views might work. Another one was somebody was talking about optimizing, Doug was talking about optimizing a calendar, and 90% of users are fine with the defaults, but a few of them have extreme numbers of events or things like that, and the memory allocation is hard to predict. So GA or GP both might be interesting in that case. It's possible to make GP restrict the solution sets rather than doing individual letters like we were talking about on that little example GP. To restrict the solution set to very discrete functions, so compositions of a web service if you have chain pipeline, or jQuery functions if you were trying to get something that would make specific tweaks to the view. So restricting the feature set might make it possible to do server-side programs that would be interesting to the user. You could do it client-side, but then you can't get the data back or transfer the data, the genes between users, which is how you pre-populate solutions into the populations that you give new users. So if you have 4 things that people probably want, you can give new users things that are close to what they'll probably want based on their other attributes, which is how it doesn't take 3,000 generations and maybe only takes 25. So that said, this is not working incredibly well, but I thought I was trying to make a toy GP algorithm which would create a sequence of that, when applied to markup, would create valid HTML. So the main thing that I want to get at is that the fitness function is ask the user. So that's again when I think it might be interesting to use GP, is when the user has very specific, strange thoughts about when they want to have double asterisk equal bold even if it's in the rest of the page. The rest of the markup is valid HTML or text style or something like that. So just to go back, so most of your users are here, they don't need GP. Or here, they don't need GP. Or here, they don't need GP. But somebody might want to have, so this would be a web service that you would feed it just a random syntax that is that is the user's ideal they desire, that is perfect for them. And if they keep hammering the web service enough with requests, one of their 200 or 500 in their population will eventually return something that that is a sequence. So this is basically parse trees are used. Parse tree. So problems that parse trees solve, GP can solve more slowly, but with more interesting and often self-modulating results. I did have a lot of problems with memory, and like I said, the algorithm really didn't work. So it would produce interesting things. I used an object store, which I had never used before, but apparently Ruby has support for keeping objects around. So they get garbage collected, but not preferential. So the opposite of preferential. And that helped a lot. And I was starting to write a anyway, I have a Backbone.js app, which illustrates some of the user interface things which allow you to gather a better fitness function from your user. So ideally, this would be italics and bold. This would be bold, and this would be bold, and this would be just italics, as an example. And you could maybe allow your users to input their own fitness functions, which would be tried in parallel with your own fitness function. So it's sort of a hybrid approach. It can crunch through the population, evolve it a bunch of times until at least all the members of the population satisfy one rule, and then go back to asking the user for more input. That doesn't really make sense by looking at this interface, but the idea is that you can get more fitness function. The fitness function here is whatever the user clicks on, or whatever the user hovers over, or whatever information you can get about what the user seems to be interested in.
So they would click on the best one of the three, or the lead. So that's three iterations, or what?
Well, so every time that you would send information back to the server, you probably want it to evolve once.
Yeah. So these are three evolutions, or three?
No, this would be probably
it's one generation, three children, and you choose the best children.
Right. And it'd be probably better if you could, do 20 on the same page.
Right.
But it's all a user interface conundrum of how you can get data out of their brains.
Yeah.
Into your.
But they need to give you back some. The fitness function. There is no fitness function. The fitness function is just
their behavior,
their brain.
Right. Whether
and they give you back some binary or close to it. Right. It sounds to me kind of like A/B testing.
Yeah, exactly.
For landing pages, for marketing pages.
Right.
You draft up 50 different bullets and 50 different side graphics and all that stuff, then you could just assemble a million. If you're getting, you know, driving thousands and thousands and thousands of page views from ads or whatever, then quickly get your optimal landing page that results in the most buys, or like Twitter bots to drive the most people to your, you know, Russian girl webcam website.
Sadly, yes, that's probably one of the low-hanging fruit. Yeah, well, so yeah, so that's my ongoing quest to make a web page that designs itself. Wish me luck.
How many times have you visited to get something to come up?
I'm sorry, what?
How many times have you have to click on things to get your web page to?
Well, yeah, that was sort of the problem, is that I was not, whatever settings that I had, you know, I think I had it set for 10, you know, 10 in a population. That was way too low, and I tried other things, but yeah, it's you just have to play around with it a lot, and there's magic there. But it is way, way, way slower than doing it in, say, C. There's no reason you couldn't take the input in Ruby and have it, you know, have, you know, part of it do it in C and then load the fitness function back up for. I think the general thing that would be an interesting takeaway for people here is just to know that genetic programming has a few libraries out there and that they're pretty easy to play with, and that it's very naive. So you only have to decide 4 things before you get started, as opposed to you know, singular value decomposition where you have to decide 15. So it's a neat, naive approach. It's not going to make things program themselves yet for a long, long time. Okay, so earlier I had posed any places where you have, this is my interpretation, but any places that you have 1 or 2% of the users who are extremely, extremely, you know, they want a better result than they're getting now. I feel like web developers who see the backsides of websites probably spend more of their time worrying about a small percentage of the population, the diminishing few. So if you can think of any applications of those, think about this as an option. And I'd love to talk about it at the pub, or if you, yeah, go ahead.
What question did you start with? Did you see genetic algorithms and you want to do something with it, or you wanted to design something that made a website design itself, and then somehow you found? I don't see how.
Originally, I started out with flashcard data, so I was trying to figure out how to classify it, and I tried to support vector machines, and that wasn't working. So I started playing with genetic programs. So the idea with flashcards, I mean, that's just how I got into it. It's my personal interest, but there are many people who are knowledgeable about it around the DC area. They don't tend to be web developers.
About having websites that design themselves?
No, about GP.
Oh, yeah. Because I mean, my first question is, what does it mean for a website to design itself?
I'm taking a pretty loose definition, because someday I'll have to declare victory.
I think that, like, if you, yeah, declare victory. I think if you, like, found the right pieces of what it meant, then you would.
Yeah, it's not cheating to just totally, like, define what a sidebar is as a, you know, as a gene. That's totally fair game.
It seems like there'd be disadvantage to having a lot of variability in a site.
I'm sure that there's many applications where it is not at all.
Yeah, I mean, I can think of some where it probably doesn't matter so much than others where it would be, no matter how bad it is, it's better than, it's worse to change it.
No, that's a good point. The user experience would suck if you just threw this at new users. It would have to be a message to a user that, you know, oh, you're on Amazon.com. You want to design a little you algorithm, so this algorithm acts like you when it goes out to search for things. or something like that. That would be the sort of message I would expect to see on the web in the next 5 years as computer processing becomes cheaper, is design yourself a mini. I'm just making things up, really.
This is already used in the
Huh?
This is already used in like ads. Like A/B testing is a very close, a very close thing to this. The only difference is A/B testing usually has you as the end step, but there's places that automatically just let the robot decide what's the best, which A/B test wins. So I remember seeing some Universal did some advertising for Spider-Man, and they made this crazy ad that had all this different text and backgrounds and colors of Spider-Man suits and all sorts of stuff. They just fed it in there, and they did like 1 million permutations, spent lots of money on advertisements, and found the one that did the best out of all of them. So it's just like this. It worked pretty well.
Yeah, I think the Huffington Post has A/B testing that decides in the first 5 minutes, which not just based on the number of clicks, but based on the patterns that are inherent in the structure of the clicks that are coming in, which headline it's going to use. So it's using structured data that's not necessarily clear, and genetic programming or genetic algorithms would be appropriate there.
Have you tried Google's API for machine learning?
No.
Yeah, well, I'm not sure if they still have it. They had a year or two ago. So it's kind of like a black box. You basically, you don't know what, well, they do tell you what's under the hood, but you just play with a few sort of parameters. You kind of specify what kind of data you have. And it's sort of like you present a training set, and then you train whatever algorithms they have. I think they have a whole bunch of different kinds of algorithms.
Right. Yeah,
you can choose, and then it works as a sort of black box that tells you the answer. Just basically feed stuff and it will.
Right. So yeah, Peter Norvig is one of the leading. Yeah, I'm sure you know, but Peter Norvig is one of the leading AI researchers, and he's also a product developer at Google. So.
Right. I think they started monetizing that last year. You can use a whole bunch of it for free, but then at some point, if you have like really heavy stuff, then I think you have to pay for it.
Yeah, and it's definitely still out there too.
What's that?
I think it's called Google Predict or something.
Yeah, I think that's what it's called. Yeah.
Google Prediction API.
Google Prediction, right? Yeah. Yeah, I suffered through genetic programming for a long time before I found that. I'm like, huh.
All right. Cool. Well, thank you very much.
Thank you, Darius.
Make up things, sit together, and some other things.
It's very pragmatic. Whatever works.
I forgot to thank you. I also want to thank JP for recording this evening's event for people who couldn't make it. Again, I want to thank Logic for hosting this group. Thank you guys. I'd also like to thank the speakers tonight, Michael and Darius, for their presentations, as well as those of you who will be volunteering to present at future DCRUGs. Thank you. Don't be shy. It's not, you're amongst fellow geeks, so it's not terribly daunting, and it is fun and interesting to do. So, speaking of fun and interesting, let's go get some drinks. Has anyone who's been there?